Hi, my name is Ahmed, and I might not know a lot about rapping or singing, but what I do know about is the physics behind drones. Drones are amazing, and they're an important part of today's changing society, from being used by farmers, to photographers, to even scientists. However, my drone here has gone through a lot as well, from epic dog chases, to being stuck on trees for days, and my brother's epic killer dance moves. Welcome to Drone Physics with Ryan Ahmed. So here we're going to be working with this little red drone. So let's move it right here so we could work on it. So what we're going to find out today is that drones have a lot of physics and a lot of math behind them because they're acted upon various forces which are really important. So this drone is going to be 1 kilogram. So we could better understand the physics behind this drone. So you know that force is equal to mass times acceleration. And mass, we already know that because it's 1 kilograms. So that's the mass. Then you have the acceleration. Acceleration in this case is going to be the Earth's gravity. And we know that the Earth's gravity is 9.8 meters per second square. Okay? So we can round that to 10. So now that we know that, it's going to be F equals 10 and 1, because 1 is the mass. That means the force, F of G, which is the gravity acted upon the drone, will be 10 newtons. So that means this little drone is going to be acted upon by 10 newtons because of F of G, because of gravity. So we want this drone to be stable. And how do we do that? Let's go right into that. Let me just erase this. Okay, so let's move it to the center. You have to have a thrust of 10 newtons. So F of T will be 10 newtons. And this will cause for the drone to be stable up in the air. It will allow for it to hover because gravity is pulling it down by 10 newtons, and the thrust of this quadcopter will push it up, thrust up 10 newtons. And this is how it will look on the vertical scale of the drone. So how many propellers does this drone have? It has 4 propellers. Okay? So with these 4 propellers, we know that since there are 4 propellers acting upon 10 newtons of force, you know that each propeller has to produce 2.5 newtons of thrust for each propeller. So then you know that each propeller will be producing 250 grams of thrust. Every single propeller is going to produce 250 grams of thrust to allow for a stable hover and without it being dropped due to gravity. But each propeller is producing 250 grams of force. Each propeller allows it for a thrust of 10 newtons. So what happens if we change that number? What happens if we take it and change it into a number like 500? So we have 500 grams for every single propeller. What does that mean? So this would actually convert into 500 times 4, which equals to 2,000. And what does that equal to? That equals to 20 newtons of force. So what happens? You will see that the drone will start going up. We can extend this line. And then we see that now there's 20 newtons of force thrusting up, which makes the drone go up instead of being stable, because gravity is only the gravity produces only 10 newtons and the drone is producing 20 newtons of thrust. So what if instead of going up and down, you want it to go to the right? Well, the drone needs to rotate, and a 45-degree angle seems sufficient in this case. So gravity will always be pulling this drone down by 10 newtons. That's going to be our constant, F of G. Okay, so there's a 45-degree now. 45-degree angle. And now the drone is trying to go here. And there's also a 10 Newton force. So, what do we do? How are we going to find out what these angles are? These other vectors that make up the 45-degree angle. So, you need to do a little bit of math. Cosine 10, and you get 7, around 7. So there's a 7 Newton force thrusting up and a 7 Newton force that's going to the right. So there's all of this. Now the drone is rotating because of the 7 Newton force that's allowing for the resultant vector to go to 10 newtons. But when you look at this, you realize that the drone is actually losing altitude. It's going down because the vector going up, it's less than the vector pulling it down. So what do? We need it to be 10 instead. So what do we have to do? We have to do a little more math. So we have to extend it. We have to extend it up and make it 10 newtons. So then it's stable. And then we also need 10 newtons here. So now we need to find out what the resultant vector is here. So what do we do to find that? Extend the line. So we now have a new resultant, which would be 14 newtons. Okay? So now you know that the drone is stable in its position while going right, and it's not going up or down, it's just going to the right with a 45-degree angle. But this here, it's interesting. The drone is going to the right. Let's look into it. It's accelerating to the right. So let's focus on only that part. So we need to go back to that same equation we looked at before, a force. F equals m times a. And we know that the mass is still 1 and there's a. We need to find out how fast this drone is accelerating to the right. And we know that F is equal to 10 newtons. So, what's the acceleration of the drone right now of it going 45 degrees and it's moving to the right? What's the acceleration of the drone right now? It's going to be, well, you do the math and you find out that A equals to 10. And it's accelerating 10 meters per second square. 10 meters second square. So now you know that the drone, if it's at a 45-degree angle, it's going to the right at 10 meters per second square.